want to identify functions from relations, and there are several different ways to define what a function is. All of those definitions are interchangeable. They all mean the same thing. They're just stated in different ways. So one of the ways we can define a function is to say that x defines y, or t defines y, or essentially one variable defines the other. This is input, and this is the output. The other is to say that there are no repeated x values. So each x tells us specifically what y is. It is not necessary that y tells us what x is, but every x must go to a distinct y. Not that y can't be repeated, but that x only goes to one y. So when we look at the relations that we have been given, a relation is just a set of ordered pairs. That can be a finite set, an infinite set. It can be ordered pairs of numbers, ordered pairs of letters, ordered pairs of objects. But a set of ordered pairs is a relation. We want to determine if these relations are functions. So here I have -4, -5, 6, and 6. I have a repeated x value. And this x value goes here to -7, or maps onto -7. And this x value maps onto -5. Therefore, x does not define y, because knowing this x does not tell me what y is. If x is 6, I do not know what y is. And so this is not a function. Here I have y, I have t, I have g, I have x. None of those are repeated. If x is y, well, if the first component is y, then I know what the second component is. If the first component is t, I know what the second component is. If the first component is g, I know what the second component is. If the first component is x, I know what the second component is. It doesn't matter that the second component is always t. Doesn't matter. That's a function. Okay, in relation number 3, if the first component is tree, I know that goes to -8. The first component is sky, I know that goes to -7. The first component is a desk, I know that goes to 1. If the first component is pen, I know that goes to -2. If the first component is chair, I know that goes to -8. And so for every first component, I know what the second component is. That is a function. And then for the next example, I'm going to draw an arrow that isn't there just so that I could change the answer to what I want it to be. I want to give you an example of a relation written with arrows that isn't a function. And as this stood, it was a function. So looking at this, if I know what W is, or if I know the first component is W, then I know that the second component is leaf. If I know that the first component is Z, then I know that the second component is cloud. If I know that the first component is T, then I know that the second component is leaf. But if I know that the first component is X, I don't know what the second component is. It could be either cloud or leaf. So that is not a function.